Hey guys, this is Carrie, and this is the answer key video for homework number 1, Unit 8, Sequences and Series. So the image below has a visual pattern. Let D1 denote the number of dots in the first image, D2 denote the number of dots in the second image, etc. So it looks like D1 is 1, 2, 3, 4, 5, 6. To go from D1 to D2, it looks like we add 3 dots, so that will be 9. To go from image 2 to image 3, we add 3 dots, so that will be 12. So it looks like we have a pattern here where we have a constant rate of change of plus 3 from one to the next. So for D4, it will be 12 plus 3 is 15, and D5 will be plus 3 again, 18. So write a formula that illustrates how to determine the number of dots in the next new image in terms of the number of dots in the previous image. So for part B, my answer would look like new equals, so to get the new image, D6, I'd have to take the previous and add 3. We saw in class today that having this rule isn't enough to completely determine a sequence, so we need to have a start value of, say, something like 6, because in this case it was 6. So this is our formula or these two equations compose our recursive formula using informal language. So what we're going to do now is in part C, rewrite these using formal notation. So for formal notation, the start value, this is D1. So D1 equals 6. For the new, that's D sub n equals the previous dn minus 1 plus 3. So notice there's a direct correspondence here. The starting value is D1. To get the new value, that's Dn. And if the new value is Dn, the value that came before is D sub n minus 1. So we use D sub n minus 1 for the previous one, the one that came before the nth one. All right, so that's done with problem 1. For problem 2, one point of clarification that I want to make, and I'm going to leave you guys to find the answer here, is that when we're trying to find this number of circles, we're actually counting these little circles. So we have 1, 2, 3, 4, 5, 6. So in this case, C1 is 6. I'm going to leave you guys to find parts B and C, and A, I guess. Good luck. For problem 3, we're going to get practice where we're given the recursive formula, these two equations, and we need to generate the terms. So to find the terms A1, A2, A3, and A4, what we're going to do is A1 is given to us for free. A1 equals 7. So we're done with A1. Looking at the next formula might be initially confusing or initially challenging. But if you look at it, A sub n minus 1, what this means is the term that came one before the one we're looking for, or in simpler words, the previous term. So our formula really is, to get the new one, we do 2 times the one that came before. So in this case, to get A2, we're going to do 2 times the one that came before, and that will give us 14. To get A3, we're going to do 2 times the previous, so that will give us 28. To get A4, we're going to go 2 times the previous, so that will give us 56. So now we have A1 through A4. Problem number 4 is a similar problem. It has a more complex recursive formula, but I think you guys can figure it out. Problem number 5 is a very challenging problem, so that's why I guess it's a challenge. I have asked you to determine the next 3 numbers in the sequence. So your first instinct when looking at the sequence might be, okay, well maybe there's a common pattern that connects one to the next. So this appears to be plus 1, plus 7, plus 15, plus wow, what is this? 37. So a not so obvious pattern here. It's definitely not a constant rate of change like some of the ones we saw before. Multiplication doesn't seem that helpful either because there is no common ratio as well. So we're looking for another pattern. And I guess when I was thinking about this pattern, when I was thinking about trying to find the solution to this pattern, I was thinking about the Fibonacci numbers. So it looks like to get 11, using 4 and 3 as my ingredients, I could say 11 is equal to 2 times 4 plus 3. So using some color coding to help, 2 times 4 and then 3 is the value from 2 before, so like that. So I'm going to propose a rule here, which is to get the next value, it looks like I do 2 times the one that came before plus the one that came previous to the previous, which would be the one that came 2 before. Let's see if this continues to work. So to get 26, we have 4 and 11. So 26 equals 2 times the previous plus the previous, the one that came 2 before. That is 26, so that does work. To check it with 63, we can say, okay, we're supposed to do 2 times the previous value, so 2 times 26, and then we'll look back at the one that came before that, 11. Let's see if this works. 63 equals 52 plus 11, and that checks out as well. So it looks like we have our recursive formula for this sequence. I know it was a crazy challenging one, but I hope it showed you the potential with recursive sequences to define complex relationships. I'll see you guys in class tomorrow. Hope you found it helpful.